what we're going to do. We're going to start by turning it over. Okay, and when you turn it over, all that does is make the exponent positive. So now you have 16 over x to the 12th to the 1/2 power. Okay, now what does to the 1/2 power mean?
Square root.
Square root. So this is the square root of 16 over x to the 12th. When you raise something to a fractional power, it means you have a radical. And the denominator tells you which root you are taking, and the numerator tells you which power you are taking it to. So the 1/2 power means the square root to the first. The 3/2 power would be square root cubed, and so on. All right, so now we're going to take the square root of this. So the square root of 16 is 4, and the square root of x to the 12th is x to the 6th. Very, very good. X to the 6th. Remember, x to the 6th times x to the 6th is x to the 12th. So the square root of x to the 12th is x to the 6th. And that's it. There's your answer. Done, because it's to the first power, so that's it. All right, what about number 2? What does 9/16 to the 3/2 mean? I just told you. What does 3/2 mean? That's a radical. And what does it mean? The square root cubed. Not times 3, but cubed to the 3rd power. So the 3/2 means the square root of 9/16 cubed. Okay? What's the square root of 9/16? 3/4. We take the square root of the top and the bottom, and then we cube it, and we get not 9, 27 over 64. We get 27 over 64. Okay, next. Oh, this is a very simple problem, but people mess it up all of the time. Be careful. How does that simplify? What's that going to equal?
1977 over C.
Yes, 1977 over C to the 2014. Why does the C go to the denominator? Because it has a negative exponent, right? Why does the 1977 not go to the denominator? Because it doesn't have a negative exponent. Only things with negative exponents change positions. All right, what about this one? All right, what about it? What do you think? Melon?
You add the -4 to the numerator 4.
Okay, so this guy is going to go to the top. So the 3x to the 4th is going to stay there, and then I'm bringing up the 3x to the 3x to the 4th because it has a negative exponent, and things with negative exponents move. Since it's in the denominator now, we'll take it to the top. Okay, now what?
Distribute the
Take everything in here to the 4th power, so we have our 3x to the 4th, and now we have 3 to the 4th, which is 81, x to the 4th. Giving me a grand total then, if I multiply all that together, what do I get? 243 x to the 8th. And there's the answer to the question.
Could you multiply it beforehand?
What do you mean?
Like in the original problem, and then like have 81 at the bottom?
You mean, you do the multiplication out? You don't have 81 at the bottom. 3 to the -4th would be 1 over 81. So if you did that, you'd have to have a fraction down there, which, I don't know. I'd rather not have a fraction inside a fraction, but you could. All right, now this one. This is a no calculator exercise. So those of you that think you're just going to type it in on the calculator, you can't. We're doing this without a calculator. I really don't want to, I mean, I can square 9, okay, but I really don't want to multiply this out, and I don't want to multiply that out, and I sure as heck don't want to divide. But what do I notice about these 3 numbers? They aren't just 3 random generic numbers. They're all powers of 9. Actually, they're powers of 3. 27 is not a power of 9. 9 to the first, 9 to the second, 9 to the third. It has 9 as a factor, but it's not a power. But these are all powers of 3. Here's what I mean. 9 is 3 squared. Would you agree with that? So I have 3 squared. Squared? What's 27? 3 cubed. Cubed? And what's 84? 3 to the 4th to the 4th. So I changed 9 into 3 squared, 27 into 3 cubed, and 81 into 3 to the 4th. So now I can do all my properties of exponents without actually doing any arithmetic, like multiplying and dividing. So this becomes 3 to the 4th, and this becomes 3 to the 9th, and this becomes 3 to the 16th. Now, what do I have on top? 3 to the 4th times 3 to the 9th would be 3 to the 13th. That's on video. And 3 to the 13th over 3 to the 16th would be, well, 3 to the negative third, or just 1 over 3 cubed. I've got 13 3's on the top and 16 3's on the bottom. So when I start canceling, that would leave me with 3 on the bottom, which is the same as 3 to the negative third. And 3 to the third is 27, so I have 1 over 27 as my answer. Now, that problem is only doable that way because all of these numbers are powers of 3. If they weren't, we wouldn't be able to do this, but they are, so we can. All right, number 6. 21 squared over 14 cubed. Now, what you cannot do is simplify 21 and 14 right now. All right, they have different exponents, so you can't do that. However, what you can do is think about 21 as 3 times 7. So would you agree that that is 3 to the second times 7 to the second? Is that okay? We can't do that with addition, but we can do it with multiplication. Kind of distribute that exponent. Now let's do the same thing on the bottom. It's 2 times 7 cubed. So what's it going to be now on the bottom? 2 cubed times 7 cubed. Now I can do some canceling because I've got 2 7's over 3 7's. So that's going to leave me with a 7 on the bottom. The 2's and the 3's don't cancel. 2 cubed is 8. 3 squared is 9. So it looks like the answer is 9/56. See how I did that without doing any like actual multiplication and division? Now let's look down at the quiz underneath because it's exactly the same thing, just a different version. What's the answer to number 1?
1 over 2.
Watch it.
3 over
3 over x squared. 3 over x squared. Don't put 1 over. It's not. It's 3 over x squared. Everybody okay with that? Number 2. 2x to the negative third over 2x cubed, all right? How are you going to start that one?
Bring 2x.
You're going to bring this guy down. So we got a 2x cubed down here already, and then down is coming the 2x cubed. And so all that's left on the top is a 1. Okay, what's quantity 2x cubed? What's that? 8x to the third. Good. So what's my answer? Altogether, I'm going to have 1 over 16x to the 6th. Now I'm going to erase this one, but look at number 3. Isn't number 3 kind of the same thing as this one? Except what? They're all powers of 2. So we've got our 2 cubed, it's sitting there. Okay, now what am I going to do with the 8? It's 2 to the third, and it's going to the 4th. All right, and what am I going to do with the 16? What's 16? 2 to the 4th, and it's going to the 3rd. What's this, you guys, right here? What's this? 2 to the 12th. What's this?
2 to the 12.
What's going to happen to these? They're going to cancel, and the answer to the question is 8. 2 cubed or 8. Please don't try to cancel anything right now in this problem. Do not cancel 7 into 14. Don't do that. Think of 14 as 2 times 7, because that's what it is, right? So 14 cubed is really 2 cubed times 7 cubed. Is that all right with everybody? Now I can cancel. So what am I left with on the top? 2 cubed or 8. And what am I left with on the bottom? Just a 7, because those 3 are going to cancel with into those 4. Okay, quickly and we'll be done. Number 5. Flip it. So you're going to start with 4/3 cubed, right? And what's 4/3 cubed? You can do that. 4 cubed, 64 over 27. And finally, number 6. What are you going to do with it? You're going to flip it because you've got that negative exponent. So you have x to the 6th over 100 to the 1/2. All flipping it does is make the exponent positive. What does a 1/2 exponent mean? Square root. So you're square rooting. What's the square root of x to the 6th? X to the 3rd. Very, very good. And what's the square root of 100? 10. There's the answer to the question. Now, we just worked through 2 little 6-problem quizzes that were very similar to each other. What do you think might happen the next time we're together?
Quiz.
Yes, over that, to make sure you got your properties learned. Okay, I think it's time for you to go. It is. Have a wonderful Halloween. Be safe and smart. Don't eat too much candy.